All right, so the first two, these are the ones, hopefully, remember these are like kind of a lot of mental math in this stuff. Number one, you can go the long way around. I can say this equals x, and then 6 to the x equals 36, and then 36 is 6 squared, so x is 2. Or when you, hopefully we're getting better at these, I look at that and I say, what do I raise 6 to get to 36? And my answer is 2, and that's it. Number 2 says to rewrite the expression. Okay, so if you've got, first of all, there's an ln and an e there. And for me, that's a heads up that there's going to be some sort of simplifying. When this e comes to the top, what happens to the exponent? Negative. It becomes negative. So this would be 2 ln of e to the negative 5. And then what happens when you have ln of e? They cancel and leave you with the exponent. So I'd get 2 times negative 5, which is negative 10. So be careful because you have to multiply there. Ln of e cancels to give you its exponent. If there is no exponent, then it's 1. But in this case, there was an exponent. It's 5. Good on those? Okay. 2 says identify the domain, range, asymptote, and x-intercept, and then graph the function. So I want to first make sure that log is by itself. If there was anything adding or subtracting, I have to move it or do the negative, that kind of thing that happened in the homework. Then I would change this to y. Then I look for my vertical asymptote, which comes from the parentheses. If x plus 4 equals 0, then x equals negative 4 is where my vertical asymptote is. Then I would have the y become the exponent and then subtract the 4. So 5 to the y minus 4 equals x. And I do my t-chart, plugging in for y. So I get 5 to the negative 1 minus 4, 5 to the 0 minus 4, 5 to the first minus 4, 1/5 minus 4, which is negative 3 and 4/5. 1 minus 4 is negative 3, and 5 minus 4 is 1. And then I plot my coordinate points. Negative 3 and 4/5 to negative 1, negative 3 and 0, and 1 and 1. It's going to hug that left side, or the right side of my vertical asymptote and point on towards the right. So what's your domain here? Close. Where's the vertical asymptote? Negative 4. So negative 4 to positive infinity. What's the range? All real numbers. Good. My vertical asymptote I already have. My x-intercept I can either get from my graph or from the center point on my t-chart, negative 3, 0. So reminder, Wednesday is your quiz on this stuff. You're going to get one graph exponential where you're going to give all those parts, one graph log where you're going to give all those parts. And then some of the stuff we did, like change of the base, I mean not change the base, but where you make the base the same from section 1, some log simplifying from section 2, and then what we're about to do, which is using the properties of logs. God bless you. Questions? 3.3 is called properties of logs. So we're continuing. This whole chapter is logs, okay, or exponential. The first thing is change of base. So what happens when you want to find the log and the base is not 10 is you can do this formula, which is called change of base, okay? So this can be done with any log, which means it can be done with just log. It could be log base 3, log base 5, log base 10, or log base e, which would be the ln. And what you do is you find the log of the number next to that log, not the base, but that one, over the log of the base. And because you can do this log base 10, this is what's called our common log. So log base 10 is the common log. And then ln would be your natural log. So it will say find the ratio of common logs or and, which one, because sometimes it'll say and sometimes it'll say or, the ratio of the natural logs, and then actually use the calculator to find the log itself. Because you don't have your calculator on your quiz, you're just going to leave it as the ratio. Like you'll give it to me as a ratio and then you'll stop there. On your test, you'll have your calculator. You'd be able to finish this out. So example 1 says rewrite the log as a ratio of A common logs, B natural logs, and then use the calculator to evaluate the log and round to 3 decimal places. So which of the numbers goes in the top? The 5. So the natural or the common log would be log of 5 over log of 8. The natural log would be ln of 5 over ln of 8. And then you'll literally use your calculator to do ln, and it doesn't matter, they give you both the same answer. Ln of 5 divided by ln of 8. You got to make sure you close your parentheses after the 5. 0.7739, so this is going to bump. Again, it doesn't matter which one you do. They should both give you the same value. Some of the calculators actually have log change of base, like the TI-84. If you go under your math menu and you go all the way to the bottom, so if you go all the way to the bottom, you're going to see, not all the way, but A says log base. And if you click there, it looks like that. And it will allow you to change your base. Oh, I just did a log of base and a log of base. It would be just one of these. I hit it twice. Ignore that. It would be just like that. So it would say log, and then you have your little spot for the base, and then you'd have your big spot for the base, okay? So you can, and let's say it was an ln, right? You could put E as the base. You could do that still, okay? But not all calculators have that. It's one of the reasons why we have changed the base. And also, without a calculator, it's still going to ask you for your ratio of common logs and natural logs. So that's going to be a question in the quiz without the calculator. Yeah. All right, now we're going to talk about expanding and condensing. There are 3 properties of logs we're going to use to do this. The first is the product property, and it says if I'm finding the log of a product, I can expand this out to be a sum. Now notice they both get a log. So if this said log of 5 of 2x, that's the same thing as saying log base 5 of 2 plus log base 5 of x. So when it starts as multiplication, we expand it out to addition. If it started as division, we expand it out to subtraction. So like log base 5 of 2 over x would become log base 5 of 2 minus log base 5 of x. And if it has an exponent, that exponent gets bumped to the front of the log. So if this said log base 5 of x squared, this is the same thing as saying 2 log base 5 of x. We're going to eventually go the other way as well, but this would be expanding. So you're starting with one log and you're expanding it out into multiple logs, okay? And if you think about the reason why all this happens, it's all related to exponents. So think about, because logs and exponential functions are inverses of each other. If I had 2 things that had exponents, the same base, and I wanted to multiply them, what do I do with the exponent? You add them. So think about multiplying turns to addition. If I had x to the 5th over x to the 2nd, what do I do with those exponents? Subtract. So again, division goes to subtraction. And if I had x to the 2nd raised to the 3rd, what do I do with those exponents? Multiply. So exponents go to multiplication. That's where all these rules originate from, okay? So part of this will be used in ways like this. This says approximate the log using the properties of logs given. Log base b of 2 is 0.3562 and log base b of 3 is 0.5646. So we have no idea what log base b is by itself, But I do know log base b of 2. You guys, can we focus, please? Log base b of 2, and I do know log base b of 3. So the first challenge here is rewriting what we're given in terms of 2s and 3s. So how can I break 6 down into something with a 2 and a 3? 6 would be the same as 2 times 3, right? So this would be log base 6 of 2 times 3. And if I have a product, how do I expand that out? Add them. So it'd be log base b of 2 plus log base b of 3. And now I know log base 2 is 0.3562 and log base b of 3 is 0.5646. And I literally add them. And I get 0.9208. All right, now go to B. If I wanted to expand this out, what happens to the exponent? It goes, actually, there's a couple different ways to do this. We'll do that first. We're going to push this to the front. -3 log base b of 3b. Now I've got a product on the inside, and the product becomes what? Addition. Log base b of 3 plus log base b of b. With me so far? What is log base b of 3? 0.5646. Good. And what is log base b of b? Good. So then I get -3 times 1.5646, and I literally multiply that out. And it's -4.6938. Questions so far? Okay, the other way to do it. Yeah, this would be if you had the quiz question without a calculator. Yeah. So think about how else I could do this. What happens when I have an exponent and a product? That would get distributed to each one, right? So this could be log base b of 3 to the -3 times b to the -3. Then we could separate it out and log base b of 3 to the -3 plus log base b of b to the -3. This -3 can get bumped to the front, and that log base b is 0.646. And then what is log base b of b to the -3? Just -3. So you could also do it that way, okay? As long as you can break it apart. The thing with logs is they can be done a lot of different ways. I would probably save this for test, not quiz. That type. All right, now we're going to expand. So it says use the product rule to expand each log expression. So A, it is the product, which means, how do we expand it? Adding log base 3 of 9 plus log base 3 of 5. Can I simplify this? Yes, how? No, sorry. You can't, so if we're adding logs, it goes back to multiplying. So once we break them apart, we're basically looking to see if I can simplify this one or I can simplify this one separately. Is there a power I could raise 3 to get to 9? 2. Yeah, this is 2. Is there a power I can raise 3 to get to 5? No, so that one stays that way. Okay, go to B. How do I expand it? Add them, good. So log of 1,000 plus log of x. What's the base on log? 10. Is there a power I can raise 10 to get it to be 1,000? I mean, yeah, 1,000. Yes, good. That's 3. Is there a power I can raise 10 to get it to be x? No. Go to C. Now it's division, which means subtraction. Log base 5 of 25 minus log base 5 of x. Can I simplify those? Log base 5 of 25 is 2. Yeah. Just fine. And then d ln of e to the third minus ln of 8. Is that as expanded as it gets?
Yes.
Ooh. No. You have two choices. One is this cancels, I get just 3. The other is if I bump this forward, I'd end up with 3 ln of e minus ln of 8, and ln of e is just 1. So either way, you should keep going until you get to that 3 minus ln 8. Questions so far? All right. See if you can do these. Work all the way through. Separate them out. Remember, the square root is an exponent of what? Square root is an exponent of what?
-2.
Close.
1/2.
1/2. Good. All right, so what happens first with A? Good. 2 gets bumped to the front. So 2 log base 5 of 7. Can you simplify that? No. So it literally stays like that.
Why did 2 go to the front?
So exponents, when you expand, exponents have to get bumped to the front. Yep. There, you cannot leave. So it's a good question because that first question, it's not that it's wrong. It's just not as expanded as it should be. So you have to move exponents. All right, B, and I will tell you that there's obviously more than one way to do this. How many of you bumped the 4 to the front immediately? Okay, good. And then how many of you distributed the 4 to the 8 and the x? Okay, they're both right. If you bump the 4 to the front immediately, you have to remember that that 4 still gets applied to both the 8 and the x when you expand it. So when I expand it, it becomes 4 log base 2 of 8 plus 4 log base 2 of x. So be careful when you have an exponent. And that would be the only reason I would say it's actually probably better to distribute it here so that you remember that they go to both, but it is still the same. They go to both. Now I'm going to look at this and I'm going to see, can I simplify log base 2 of 8?
Yes.
That is what?
3.
Good. And then it is 4 times 3. So this is 12 plus 4 log 2 of x. All right, go to C. We said it just a little bit ago, but the square root is the same thing as what kind of exponent?
1/2.
1/2. So this is the same as saying log of x to the 1/2, and that 1/2 has to get bumped to the front. Can't leave an exponent when expanding. All right, and then ln 6e to the 5th. Again, you could either bump that 5 to the front, but then make sure you give it to both. Or I could distribute it here, and I'd get ln 6 to the 5th plus ln e to the 5th. The 5 has to get bumped forward. 5 ln of 6 plus ln of e to the 5th is 5. Good. ln and e cancel. Yep, give you the exponent. Questions? Okay. Go to the next one. Wait for it. All right, so for A, you again have choices. You can push the 2 all the way to the front, okay? Or you could distribute the 2, and I'd get log base b of x squared times what happens when I square the square root of z. It's just z, so I eliminate that. You could also make the exponent on z 1/2 and then multiply that 1/2 by 2. It goes to 1. Either way, that one gets eliminated. When I expand, the multiplication goes to addition and the 2 goes to the front, but just on the x. So this would be log base b of x squared plus log base b of z. And then just the x one gets the 2. So 2 log base b of x plus log base b of z. Questions on that one? Yeah.
What happened to the square root on z?
the square and the square root canceled out.
Oh, okay. You just, okay.
Yeah. If you had put it on the front, Xavier, if you put it on the front and then you had z to the 1/2, it would still end up simplifying.
Okay.
Because you'd have z to the 1/2 and then the 1/2 would pump to the front and you get 2 times 1/2, which is still 1. All right, B, this would be, again, these both get the exponent of 3. So this is log base 5 of 25 to the third minus log base 5 of y to the third. What is log base, well, there's 2 different ways to do this. Log base 5 of 25 to the third, you can either bring the 3 to the front. 3 log base, what's 5 of, log base 5 of 25? It'd be 2. So this becomes 2. And so that first term is 6. Minus the 3 has to come to the front here. 3 log base 5 of y. You could have also rewritten 25 as 5 squared. And then that becomes log base 5. 5 squared raised to the third is 5 to the 6th. And that cancels and gives you the 6. So there's, again, a couple different ways to do it. No matter how you do it, it should end up with the same answer at the end. All right, then C, this would be log base 9 of 81. Now there are 2 things in the bottom. So they both get a minus. This is minus log base 9 of x squared minus log base y to the third. What is log base 9 of 81? 2. These come to the front. This 2 goes to the front. This 3 goes to the front. So I get 2 minus 2 log base 9 of x minus 3 log base y. Or log base, I lost my log base there, of 9. So again, anything in the bottom, if there's more than one part in the bottom, they would all get the minus. If one of these was up here, let's say the y was at the top, the x squared term would be the only one to get the minus, and the other 2 would get the positive. So if it's in the top, it's positive. If it's in the bottom, it's negative. Still good? Okay, now, which is condense. Notice they are the same 3 properties. They are just flip-flopped, okay? If you have it expanded, and you will know the difference because it starts with more than one log. If it's expanded and I want to condense, addition goes to multiplication, subtraction goes to division, and the number on the front becomes the exponent at the back. So now we're going the other direction. All right, so the directions say write as a single log. The directions moving forward will literally say expand or condense. So you'd have to look at it and know there's multiple logs here. That means I'm going to condense, or other way around. If there's one log, you're going to expand. All right, so this is addition, which means this becomes log base 2 of 4 times the square root of 8. And we're literally just going to leave it like that for now. Then I get log of 6x minus log of 6. The minus means division. Log of 6x over 6. Again, we're going to leave it like that for now. If it said to simplify, this would become log of x. C has the 2 on the front, so this has to become the exponent on the 9. And then it has subtraction, which means division. So this is log 3 of 9 squared over 27. And again, we're going to leave it like that for now. Eventually that would simplify. And the last one, you've got ln, same rule as logs. This 5 goes to the exponent here. And then it's addition, which means multiplication. Ln of x minus 2 times x to the 5th, which can be written in either order. Order doesn't matter because it's multiplication. Yep.
And we can only do that if they have the same base.
Correct. Good point. You can only do it if they have the same base. Yeah, they should all have the same base. But if it was If there was a base that was not the same, you could not condense it. Yeah. Say that again? No, they would both have to have an ln. Good question. So like if that said ln of x minus ln of 2, that's when it becomes division. If it's inside the parentheses, you can't. Good? Any questions from 3-1's homework or 3-2's homework?
Well, I have one.
Okay.